All right, take two. We are starting on page 8 with this video. We're building upon our last lesson where we did a simulation to check to see if our hypotheses were correct of Miss Gallus's free throw shooting. Now we're actually going to run a statistical simulation, a statistical study using our calculator. I'm going to show you a website we can use as well. All right, so we're going to remind ourselves of our hypothesis that our null hypothesis was that Miss Gallus is an 80% free throw shooter. Our alternative hypothesis is that she is less than an 80% free throw shooter, and that was based on she made 32 out of 50 for 64% in her one trial that we saw. A couple conditions we have to check to make sure we can use normal distributions. First, a normal one you've seen, large counts, n times p, n times 1 minus p, 50 times 0.8, 80%, or 1 minus 0.8 for 20%. Those both check out. Randomness, we have to check that. Sure, it's just randomly shooting 50 shots. And then we have a new condition here, 10%. That tells us the sample size is less than 10% of the population. And this 50 is probably less than the total population of all the free throws that she shot. We're going to find the mean. The mean here is just going to be our p-value of our proportion value of 0.8. In the standard deviation, you should recognize this formula, square root of p times 1 minus p over n. So 0.8 times 0.2 over 50, this is kind of rounding to 0.056. Moving down to 4, 5, and 6 here. In 4, we're going to label our normal curve here. So n for normal, this is our mean 0.8, and the standard deviation that we just found, 0.056. We're going to see how far, how many standard deviations below the mean is our 64% that she made. So we're going to find our z-score. That'll be the value we have, that 64% minus the proportion we're given, that 0.8, over the standard deviation we just found. So there's your 64% minus your 0.8 over 0.056. That gives us approximately negative 2.86. So right now you should be thinking, all right, my z-score is a larger number than negative 2. So it's probably pretty unusual. So here's where our 0.8 is. That's our mean. Our 0.64, that's what she shot. That's more than 2 standard deviations below the mean. And we're going to shade to the left because we're talking about less than. We can either go to table A using that z-score and figure out the p-value, or we can do normal CDF. So remember, normal CDF will hit second vars, and we want to go to number 2. And we're going from negative infinity to 0.64, and our mean and standard deviation are 0.8, 0.056, and that'll give us approximately 0.002, which is about 0.2%. So because this 0.2%, this 0.002 is less than 0.05, we have convincing evidence against the null hypothesis, and we can reject the null hypothesis. On the next page, we have our important ideas here, the conditions, the 3 conditions we talked about, randomness, the 10%, that the sample is less than 10% of the population, or 1/10 of the population. Our large counts, NP, is greater than or equal to 10, and then n times 1 minus p, sorry I wrote that a little backwards, is greater than or equal to 10 as well. We have our normal curve here with our mu and our standard deviation, our formula for mu, our formula for standard deviation, our formula for our z-score. You can either use table A or your normal CDF to find the p-value. Another way we can do this, so I even wrote down your normal CDF right here. Another way we can do this is going to our calculator and doing a 1-prop z-test. So I've written this down up on the top here. So we can go to stat over to test number 5. We have our p sub 0, that's our proportion or mean proportion, our true proportion of 0.8 that we're assuming is correct. She made 32 out of 50 shots, and we're testing to see if her percentage is less than that. And we go to calculate, and it tells us approximately the same z-score we had, and definitely the same p-value that we had. So you can do either the z-score and compare that to what the z-score should be, or I think we're going to mostly stick to probably doing this 1-prop z-test, and I have all that notes written up there for what I'd expect to see. I do have another thing that you can use as well, the website that I've linked to on the, almost made it, there we go, mathcracker.com. That'll bring you right here for z-test 1 population proportion. we have that our null hypothesis is that p is equal to the 0.8 that we're talking about. Our alternative hypothesis p is less than the null hypothesis, the 0.8 that we're talking about. There's our p sub 0, our hypothesized population proportion, 0.8, sample size of 50. Favorable cases, how many times should you make it? 32. And significance level, that's 5 for 5%. That's what we're going to be comparing to. When you hit solve, it takes a few seconds, maybe like 15 to 30 seconds, probably less for your faster computer speeds than mine, to give you all this output here. Sample size is 50, favorable case 32, sample proportion, it does the division for you, 0.64 there. Significance level, that was 5%, changed to 0.05. Writes down our null and our alternative hypothesis right here. This is a left-tailed test. We'll talk more about left-tailed, right-tailed, or two-tailed tests shortly. Rejection region, so here's where you can compare the z-scores. So going from a 5% or 0.05, that z-score is the left side, negative 1.64. If you look up on our table A, that 5% gives us that z-score of negative 1.64. So we're looking to say a z-score less than negative 1.64 that will reject. So when we calculate the z-score, got negative 2.28. That's a little different than what we got because I think we rounded the 0.056 down here. So it's a little smaller, but it doesn't really affect, and because we see that the z-score is actually less than the z-score we're comparing to. Otherwise, what we'll probably more generally end up doing is finding the p-value, and this tells you what the p-value is, 0.002, and that is less than 0.05, so we can say the null hypothesis is rejected at the 5% significance level. So there's enough evidence to complain that the population proportion p is less than p sub 0 at the 5% significance level. It even goes into confidence interval here and gives you some more fun stuff as well. So what I want you to do is, using your calculator or using that website there, I want you to go ahead and try this check for understanding. And then when you have that, go ahead and look at the PDF right below this video to check your answers.